Hey everyone, so today we're going to be going over how to solve simple algebra equations. Now for the first example, we have x plus 7 is equal to 10. Now if you know how to do this, try and do it on your own before I do it. But for those who don't, all we have to do here is we have to remove that plus 7 by doing the opposite operation. So if we subtract 7, that will cancel. If we subtract 7 here, we'll be left with x is equal to 3. And then when we plug it back in, 3 plus 7 is equal to 10. So that's our check. Let's try a different example. Let's go x plus 12 is equal to 19. Now try this on your own before I do it, but if we subtract 12, those will cancel. We can subtract 12 here, and we'll be left with x is equal to 7. And then when we try to check, 7 plus 12 is in fact equal to 19. Let's try another example. Let's do x minus 8 is equal to 12. Now it's the same thing as before, just now instead of addition we have subtraction. But the opposite of subtraction is addition. So we add 8 here to cancel that out. We add 8 here, and we're left with x is equal to 20. And then when we try to check, 20 minus 8 is in fact equal to 12. For the next example, let's go x minus 3 is equal to 21. Now for this, once again, we just do the opposite operation. So we add 3, and x is equal to 24. And of course, to check, 24 minus 3 does equal to 21. So we're good. Now let's switch it up. Let's go 9. For the fifth question, let's go 9 minus x is equal to 8. Now for this here, don't overthink it. We want to remove that positive 9. We want to get x by itself. So we subtract 9 to have that cancel out. We subtract 9 and we're left with negative x is equal to negative 1. Now that negative in front is a negative 1, and it's really a multiplier. So if we divide, the opposite of multiplying is dividing. So if we divide by negative 1, that'll cancel. If we divide by negative 1, that cancels, and we're left with x is equal to 1. And then if we want to check, 9 minus 1, 9 minus 1 does equal 8. And that's your answer. Let's try a different example. Let's do 5 minus, I keep doing that. Let's do 5 minus x is equal to 8. Now try this on your own first, but it's the same process. We remove the 5, and we're left with negative x is equal to 3 this time, and we divide by negative 1, and we're left with x is equal to negative 3. And when we try it, negative 3, 5 minus negative 3, subtracting a negative is the same as adding a positive, is equal to 8. So that, in fact, is true. Let's try another example. Let's do 4x is equal to 28. So this whole time we've been doing addition and subtraction. Now we have multiplication. And what's the opposite of multiplication? It's division. So to isolate x, we divide by 4, and x is equal to 7. And then to check it, we just go 4 times 7, which in fact equals 28. And that's your answer. Let's do a similar question. Let's go 7x is equal to 49. Now try this on your own, but you'll see that it's the same. You just divide by 7 to cancel that out. You divide by 7, and x is equal to 7. And then to check, you just go 7 times 7, which is equal to 49. Now let's try a little bit of a different example. Let's go x over 5 is equal to 20. Now that we're dividing, we just have to think, what is the opposite of dividing? And the answer is multiplication. So you multiply this by 5, that cancels. You multiply this by 5, and you're left with x is equal to 100. And to check, you can go 100 over 5, which in fact equals 20. Let's try another example. Let's go x over 6 is equal to 3. Now pause the video and try this on your own, but once again, we just get rid of that division by multiplying. We multiply this by 6, those will cancel. Multiply this by 6, x is equal to 18. And then you check it by plugging in 18. 18 over 6 is equal to 3. So x does equal 18 there. Let's try one last example. Let's go 10 over, actually no. Yeah, let's do that. Let's go 10 over x is equal to 5. Now here, what we're doing is we want to get the x to where the 5 is and the 5 to where the x is. So we multiply x here, we multiply x here, and we're left with 10 is equal to 5x. And now this is something we know how to do. So we can divide by 5 here and divide by 5 here, and we're left with 2 is equal to x. Or instead of doing that, we could also just go back to the original equation, which was 10 over x is equal to 5, and treat this as two fractions. So we can put a 1 down here, 5 over 1, and then we can just cross multiply. So 10 and 1, x and 5, and it'll give you the same thing. It's just two different ways of thinking of it. You're left with 10 is equal to 5x, and then you divide by 5, and 2 is equal to x. Let's try one more example like this. This time you guys do it on your own. Let's go 12 over x is equal to 4. Now pause the video and do it on your own, but 4 over 1, and then 12 and 1, x and 4, 12 is equal to 4x, divide by 4, divide by 4, and 3 is equal to x. Now let's try some two-step equations. Let's go for question 13. Let's go 5x plus 3 is equal to 18. Now, as we went over earlier in a previous video, bed mass is the order that you do your equations in, the order that you solve them or you evaluate them. Now when we're doing this, we want to do reverse bed mass. So we want to go subtract, add, multiply, divide, exponents, and brackets. Like when we're doing the opposite, that's the order we'll go in. So 5x plus 3 is equal to 18. First, we have to do the opposite of adding 3, which would be subtracting 3. That'll cancel. we'll be left with 5x is equal to 15. And we know what to do from here. We divide by 5, that cancels. We divide by 5, and x is equal to 3. And if you want to check, you can do that. 5 times 3 plus 3 is in fact equal to 18. One last question. Let's do 9x plus 5 is equal to 50. I'll write that a little nicer for you guys. 9x plus 5 is equal to 50. Now pause the video and do this on your own first. But once again, we subtract by 5, so those cancel. We subtract by 5. 9x is equal to 45. You divide by 9, you divide by 9, and x is equal to 5. And to check, 9 times 5 plus 5 does equal 50.